Alright, today we're going to take a look at how we get distance traveled for vectors. And to do this, we're going to use parametric equations. What you may recall nice about parametric equations is that it defines a function in terms of the horizontal and the vertical component independently from each other. For example, let's say I have a particle that's moving along this curve right here. I can take a look at its horizontal component and its vertical component independently from each other, which is nice. So we can tell that this particle is moving to the right and it's going up, so it's up and to the right. Now I can use this to get the distance traveled, to get the distance between A and B. But to do this, we have to use a little bit of a trick. We have to use velocity. Now, why do we use velocity? Because we know to get distance, it's from elementary school, it's rate times your time. That's my velocity. This and the r here is the slope of my graph. At any given point, r, my rate, is my slope. And this t, that's my change in time. Now, using a little bit of, now how this works is very simple. So imagine if I just look at the slope of the graph, the rates at which they're changing. So basically, the sense of slope, I need the rates at which the graph is changing. So if I take a look at my particle here, I'm going to use the head to tail method. Horizontally, I know the particle is moving at this distance, x prime of t. There's this rate. Vertically, I'm going to go down and it's going up there. It's going to be y prime of t. Well, if I want to find this distance right here, this distance right here is the actual rate of the particle. That's how fast the actual particle is moving. We call that the magnitude of the particle. It's called the magnitude. And to get the magnitude, it's very simple. It forms a right angle. So to get the magnitude, it's just the following. It's just the square root of x prime of t squared plus y prime of t squared. And that's how we get magnitude. This is the actual speed or the rate of the particle right there. But remember, I want a distance. So let's kind of go here. Remember, distance is our rate times your time. Well, using a bit of calculus, right, the rate is really the magnitude of the velocity times your time, which we're going to call dt. Oh no, because that's my change, again, my change in time. And this should look a little familiar to us. So to get, now remember, but dt is very small, it's very tiny. dt is not big at all, so it's infinitely tiny. So what's really kind of going on here, we're taking these infinitely tiny little times and we're going to find them all out, okay? So velocity times time, so it's the slope times the change in time. The slope times the change in time. The slope times the change, and there's infinitely many of them. So to write this, I have to use integrals to get the right answer here. dt from A to B. So in other words, and if I replace it with my magnitude I found here from A to B, we're going to get the square root of x prime of t squared plus y prime of t squared. Don't forget the dt. And that's how we get distance traveled using with vectors. So hope you guys enjoyed it. It's kind of a fun little thing to do, and I'll talk to you all later. Bye-bye.